So we begin our class today with thin lenses, and this is quite interesting. CBSE covers it in much more detail as compared to Cambridge. Thin lenses, and this is a unit of 3.2.3. Okay, so a lens is something that we are wearing. So when we talk for lenses, the two type of lenses that you will be dealing with are concave lens and convex lens. If you study this portion, that is ray optics portion from CBSE, then CBSE deals first with mirrors and then deals with lenses. Whereas in Cambridge, there is no dealing with mirrors at all. You are dealing only, so this is something where CBSE it is detailed. We are right now in CBSE, we are doing mirrors. We are doing mirrors, okay? So when we study lenses, so just for your knowledge, mirrors are also of two types, concave and convex. So thoda sa mirror samajh lete hain, then it will be easy for us to understand lenses. Okay, so try and think of a shape which is a hollow glass sphere. What is this? This is a hollow sphere. A hollow sphere, and this hollow sphere is made up of glass, means it is like a football. And so I can't show you in 3D, so I'm showing you in 2D. You might be thinking that this is like an earring, that hoop wala. It's not earring, it's a ball, right? In this ball, what we do, we cut out this much portion, say suppose this much portion, and then we have, obviously we'll have a center of this particular thing, and we have cut out this much of curved portion. So what did we cut out? We have cut out this much portion. Try and visualize it. You might be thinking this is a broken piece of a bangle. No, this is like a saucer of a cup and saucer. Or if you think about, now I'll give you examples you remember. As I told you, Jewish men, if you remember, Jewish men, they wear caps on their head that small. A waisa shape hai. Do you get it? So this particular shape which you get, I've kept it in this orientation. I can also keep it in this orientation. Have you understood? Just ulta karke rakha hai. The saucer is kept like this, and here the saucer is kept like this. If I make this in mirror, we call this as rough side. If I make this as rough, so this is my rough, and if this is the polished side, polished means it is also known as the smooth side, or it is also known as the reflecting side, then such a mirror can be thought as if like there is a small boy and the boy is sitting under a cave. Cave ke andar baitha hua hai is the way to remember. So such mirror will be known as concave mirror. Concave mirror. Have you understood? So how does a concave mirror look like? In concave mirror, always the bulging out side is etched. Concave mirror can be this way also. Concave mirror can be this way also. Remember, the reflecting side is always this one. This is the reflecting side. Clear? The other type of mirror that we can form is in which we etch the cave side. What we etch, or we say we make it the rough side. So this is my rough side. And this one becomes my smooth side. Have you seen the mirror that is there in the basement parking, which makes you alert of any vehicle that is coming? So if you see that mirror is bulging outwards. It is also kept in shops to prevent shoplifting and other thing, where they are used as security mirrors. Such a mirror will be known as my convex mirror. So how does a convex mirror look like? A convex mirror can be this way, in which the reflection happens here, or it can be this way. Have you understood? Both have been cut out from a hollow sphere. Both have been cut out from a hollow sphere. And this C, which is the center, is known as the center of curvature. This center is known as the center of curvature. And the radius of this hollow sphere is known as R, is known as the radius of curvature. Something that you don't have in Cambridge, but nothing wrong in knowing it because you will definitely need it in 11, 12 and all. Okay. Our story is about lenses. What is the beauty about lenses? Lenses do not have a polished side and a smooth side. Lenses are transparent. So you can see from either side. Like a lens is like a glass. Now, lenses are said to be concave and convex. Before that, how does a convex one look like? A convex lens is usually shown in this manner. And a concave lens will be shown in this manner. Okay. Now it becomes for you will say, sir, how did this thing come and how did this thing come? Well, before concave, we should first understand what is a plano-concave. Plano-concave. Again, not in your course, but if you know it, it's better. A plano-concave, sorry, plano-convex. Plano-convex. A plano-convex has one side straight and one side like this. This is a plano-convex. Two plano-convex joined end to end gives you a concave convex. Like this is, makes sense now? Okay. And we should also know what is a plano-concave. Plano-concave. A plano-concave will be something like this. Two plano-concaves joined back to back gives me a concave lens. Our study in Cambridge starts from concave and convex. Is this clear? Any doubt out here? Usually you should know mirrors and lenses. Okay, when we study mirrors, mirrors are all the ones which will be studied as a part of reflection. Understood? Lenses are the things which will be studied as a part of refraction. Sir, what is refraction? Bending of light as it moves from one medium to another, and the bending is usually due to the change in speed of light. Refraction always happens at the interface. Now you remember. So you studied refraction with all like glass slab and other things. This is refraction due to spherical lenses. Whenever the ray can go through, it always undergoes refraction. So our study will be refraction based on lenses. Chale aage, chaliye. So let's go to the next slide and let's study about convex. When we study ray optics and all, convex lens is studied for say 95% part. We'll always study convex lens. This is the lens which is studied more in detail. Okay. So we need to now understand what is a convergent and divergent lens. Convergent lens. Before understanding convergent lens, let us get used to some geometry and some callouts. So the callout is something like this. So try to have your protector with you. Protector, if you use your protector, your lens figures come very nice because the curves are then absolutely in the right order. This is my concave lens, sorry, convex lens. Okay. So there will be a center of this which is usually denoted by O, and my O is known as the optical center. Optical center. Thin lenses are all these lenses that we wear. Thin optical center. Right. What in Cambridge, what they do now, some topics they are very advanced, some topics they leave out many things. You should at least know a little bit of. My heart doesn't agree. Let's understand two more topics here. I'll be using this word ray optics and another known as wave optics. Let's understand the difference between these two parts of physics. Ray optics. Optics is the study of light. Light is something which in physics has got dual nature. Light has been considered as to follow the particle model, also the wave model. There are certain things like formation of shadows and other things. Light is a particle. Again, light carries energy. And when light bends around the corner, light follows a wave model. So, in order to understand the geometry of light, we bring something called optics into it. Optics is all about understanding the geometry of everything associated with light. So these are all actually, you can say, conceived, or what do you say, kalpanik hai ek tarah ka. There's like a concept of ray. There's nothing called ray. Ray we have actually imagined for us to understand how a ray, how the light propagates. Beam. In actual, there is nothing called beam. All these things human being has actually, the scientists and the engineers have conceptualized so that you can understand how image formation and other things take place. So what is the difference between ray optics and wave optics? If the size of the objects are substantially bigger than the wavelength of the light that is coming, say for example, I take a mirror, the size of the mirror is very big. It is way big as compared to the wavelength of light. Wavelength of light will be some in nanometers, and the size of a mirror is some half a meter or an inch. All these fall under ray optics. In ray optics, the size of the object where the light goes and hits are very big in comparison to the parameter of light. What are the parameters of light? Frequency, wavelength. So the objects are very big, we call it ray optics. What you are going to study now is all about ray optics. What you studied in the chapters before, like diffraction, you studied about little bit about, bending of light, those fall under wave optics. So what is wave optics? When light hits objects whose sizes are comparable to that of the parameter. For example, very small hole, very small hole. Sir, how small? You cannot see with your naked eye. You cannot see with your naked eye. At that time, the branch of physics that we are studying is known as wave optics. So in wave optics, we will not be using like ray diagrams the way we will be using ray diagrams now. So what are we studying now? Now we are studying ray optics. Ray optics can deal with reflection. In that case, you are studying mirrors. Ray optics can also deal with refraction. In that case, you are studying lenses. Make sense now? Okay. So we are not studying wave optics. Wave optics we have already studied. Like when diffraction, wave front and all those were wave optics. So there is something called the optical center. And then we have an imaginary line. We have an imaginary line that actually passes through this optical center. So there's an imaginary line that passes through the optical center. And this imaginary line, okay, this imaginary line is known as the principal axis. What is the principal axis? The principal axis is an imaginary line that passes through the optical center. Have you understood? And in such a manner that the axis of this lens, the lens will definitely have an axis. The axis of the lens is kept exactly, say, perpendicular to the principal axis. The axis of the lens is kept perpendicular to the principal axis. Clear? Right. Now we define that what do we understand by a convergent lens. Before defining convergent lens, there are some more parameters that we need to address. Then convergent lens will become clear. Isko rakh lete hain. So this is 1. So I'll say a 0.5. We need to understand what is principal focus of a convex lens. What is the principal focus of a convex lens? Right. To understand principal focus of a convex lens, we take rays of light. And how are the rays of light taken? The rays of light are taken parallel rays. Now parallel rays can come parallel to principal axis. Parallel rays can come parallel but not parallel to the principal axis. But when we define the what you call the principal focus, we will be always considering rays which are parallel to the principal axis. Now you may ask, sir, why are you so biased? Can't rays? Rays can go in any manner, and all that you are studying is all conceptual study. काल्पनिक है, ऐसा कुछ ray होता नहीं है. We are studying this in order to understand how image formation takes place. So let us take some, what do you call, parallel rays. Rays which are parallel to the principal axis, close and parallel to principal axis. So we say, when a beam of parallel rays, try and understand, when a beam of parallel rays which are close and parallel to the principal axis, are incident on a convex lens. What type of lens is this? This is a convex lens. Obviously, these are coming from air. Do you agree? These are coming from air. What is happening here? They are entering inside glass and they will again go into air. So don't you think there's a change of medium? There's a change of medium. These rays will undergo refraction. Refraction means these rays will bend. They will bend. And how is the bending? Rarer to denser, they will always bend towards the normal. Now this bending has been observed very unique. So the bending will be, I will change my colors so that you can understand properly. You will find that all these rays, when they come out, they converge at one point. These are the refracted rays. They will all converge at one point. Have you understood? They converge at one point, and this point where they are converging, this point will be known as my principal focus, denoted by F. This is my principal focus, denoted by F. So let's first understand what is the principal focus. The principal focus, listen to me, then you can automatically, definitions and all you will get in book also. Let's understand. The principal focus of a convex lens is a point on the principal axis at which a parallel beam of incident rays parallel to the principal axis converge upon after getting refracted by a convex lens. Nothing of an issue. Let's first understand in simple language. Principal focus क्या है? वो पॉइंट जहां सारे पैरेलल रेस, कौन से पैरेलल रेस? पैरेलल टू प्रिंसिपल एक्सिस जाके मीट कर जाते हैं. इसी को इंग्लिश में बोलना है. व्हाट आर द कीवर्ड्स वी शुड मेंशन? इट्स अ पॉइंट. द पॉइंट इज ऑन द प्रिंसिपल एक्सिस. इट इज द पॉइंट ऑफ कन्वर्जेंस ऑफ व्हाट? रिफ्रैक्टेड रेस. व्हिच टाइप ऑफ रिफ्रैक्टेड रेस? पैरेलल रेस व्हिच आर पैरेलल टू द प्रिंसिपल एक्सिस. अब इसको इंग्लिश में समझाते हैं. द प्रिंसिपल फोकस ऑफ ए कॉन्वेक्स लेंस is a point on the principal axis where a parallel beam of incident rays parallel to the principal axis converge upon after getting refracted by a convex lens. She's laughing, thinking that how the words are coming one by one. It will come to you also. I said, either you mug up the definition or you break it up into your mother tongue or any language. The best word I always say, remember the keywords. Point, principal axis, convergence, parallel rays, parallel to principal axis, refraction. ठीक है? लिख दूं क्या? Should I write it? Oh, she's asking, can you please write it? Okay, now fine. So we write the principal focus of a convex lens is a point. But I'll write it. Nidhi, have you understood or not? Is a point on the principal axis at which a beam of parallel rays parallel to the principal axis converge upon after being refracted by a convex lens. As simple as that. Refraction के बाद, after refraction, all of them converge upon. क्योंकि ये लेंस सबको कन्वर्ज कराता है, इसलिए इस लेंस को हम convergent lens बोलते हैं. Why do you call it a? See, you understand? I could have straight away given you the definition of convergent lens. Doesn't make sense. Why do you call it a convergent lens? Because this lens's job is, I am the lens. If a parallel beam of rays come and hit me from backside, I converge all the rays to a point, and that point will be known as my principal focus. Now you should ask, sir, if you are saying principal focus, is there a secondary focus, vice principal focus also? We don't say vice principal focus, we say secondary focus. Obviously, if the rays of light would have come from this side, see, if the rays of light would have come from this side, they would have converged on this side because it's a lens. Do you think from my specs rays only go this way? It comes from this side also. But in optics, the convention that we use, sunte bhi jaiye, the convention that we use is rays are always incident from the left hand side to right hand side. Please understand, children. In optics, we say that the incident rays are always incident from the left hand side to the right hand side. You may say, sir, who gives you this permission? Can't it be from right hand side to left hand side? Yes, it can be. But the convention is this. Therefore, this focus will be known as my principal focus. So don't we think that there should be a focus on this side also? Yes. This we denote as F dash, and we call this as the secondary focus. However, for all numericals and everything, this is our pyara bacha, and we will be loving this one more. We will be stepmother on that. Have you understood? There is a secondary focus, a lens. However, in a mirror, you don't have two focuses. Because why don't you have in a mirror two focuses? A mirror has only one shiny side. So whatever has to happen will happen on one side of the mirror, not on the other side of the mirror. Not on both sides of the mirror, the better English. Do you understand? So in lens, it is always. इतना आपको समझ में आया? Right. Now a little bit more, थोड़ा सा और high level समझ लेंगे, then it will become more clear for us. So convergent lens and principal focus. By now, you should ask yourself and ask, do I understand what is principal axis? Do I understand what is convex lens? Do I understand what is optical center? Do I understand what is principal focus? You ask yourself, do you understand what is a principal axis? Can I take it? It's an imaginary line which passes through the focus and optical center, right? What is the convex lens? A lens which is bulging on both sides is known as my convex lens. What is the optical center? The center of the bulge out lens, the core center, is known as the optical center. What is principal focus? That point on the principal axis where all the rays which are parallel to the principal axis converge upon after suffering refraction. Fair enough? Okay. So this is all we have understood. Do you also understand what is secondary focus? Well, every lens will have two focus. One, the primary, which is known as the principal focus, the focus that you obtain as per following the rules of optics. And obviously, there would be a focus on the other side also. Now, since you have understood this, we will also understand something called focal length. What is the focal length of a convex mirror? Sorry, convex lens. Focal length is always distance between optical center and focus. Distance between optical center and focus. So what is your focal length? My focal length will be denoted by F. Clear? Any issues? None? Okay. Can I go to the next slide? Okay. So let's understand one more thing. Now this is my principal axis, and let's say this is my convex lens. Agreed? So if this is my convex lens, we all know that there is a focus somewhere here, and say this is an imaginary line which is passing through the focus in such a way that it is perpendicular. So understand, I am the lens. You have put a rod through me, so that is the principal axis. The focus is on that side. There is another rod there. Okay. So here, if children try and understand, on that rod, I am trying to put one A4 page. What am I trying to do? I am trying to put an A4 page on this particular rod. Then what I have made is basically known as a focal plane. Focal plane. Plane. How many planes are there at a point? Indefinite number of planes. As your hand can rotate and swivel around a point, that many number of planes we have. Plane is just like a A4 page. It can be in this orientation, so many orientations. We are in 3D now. So this is the focal plane, which is exactly perpendicular to the principal axis. To understand, there's a rod and the rod is going through this curtain. This curtain is the focal plane. Understood? And that dot, 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 dot line is exactly the axis of the curtain. So this is the axis of focal plane. Right. So what did we learn? We learned that if you now have a parallel beam of incident rays which are parallel to the principal axis should come and converge upon the focus. Yes or no? This is my focus. This is my focus. The whole family is behind this project of creating Microsoft Teams login since last night. They've succeeded. Okay. What if my rays are parallel, but my rays are not parallel to the principal axis? This is what your book will not deal. And I think you should know this. So this is the axis of this lens, right? So I have now rays, and these rays are what? These rays are coming parallel to each other, but they are not parallel to the principal axis. Have you understood? They are not parallel to principal axis. What happens to these type of rays? These rays will also merge. They will not merge because it's a convergent lens. It will converge. They will not merge at the focus. They will merge at a point on the axis of the focal plane. Why this was drawn by me, you will understand when we actually do a particular what do you call a case, and there it will become clear. Say suppose they are all merging. They're all merging. All merge. Now the point that you have got, you don't have the right to call it the focus. अब आप इसको focus नहीं बोलेंगे. It's a point on the focal plane. Have you understood? Now you understand why we use the word parallel to principal axis in the previous example. If you look at the previous example, why the rays were parallel? The rays are parallel. Sir, does a focal plane exist here? Yes, it exists here. Here the convergence will happen at the intersection of the axis and the principal axis. Here the intersection will happen at any point on the axis. This is known as the focal plane. So tell me children, have you now understood what is principal focus and what is a convergent lens? Now it should be absolutely clear in your mind. Now we recall if you have done some fun things in your childhood. Girls are not that naughty. Boys must have done it. So let's think of a hand lens. Hand lens. You know what's a hand lens? The one that a doctor uses or an astrologer uses. Something like this. Which in your daily language you call as magnifying glass. All right, this is called a magnifying glass. A magnifying glass is nothing but a convex lens. Convex lens means it's a convergent lens. Okay, it's a convergent lens. Fine. Okay. Some more assumptions in optics. We say distant rays from far off sources. Rays from far off sources, there can be any celestial body or the sun, are considered to be parallel. Rays far off object, any far off. So based on this, can I say sun rays? Sun rays means in the language of optics, whenever geometric optics, we call it geometric optics. When we are doing geometric optics, can we not take sun rays to be parallel because the sun is at a very far off distance from us, right? So I don't know how many of you have done that mischief. If you take the hand lens and you take some small pieces of paper right in the afternoon or sometime, and if you put it on that paper, you will see that a very sharp dot gets formed on the paper, and the paper after some time starts catching fire. What you are doing is that you are such a mischievous child. These are distant rays from the sun which are converging on that paper, and the entire energy of that sun, if you do this on anyone's eyes, the eyes are gone forever. That's why you are not supposed to make a ulta telescope and see. Have you understood? This is exactly the phenomenon that happens in a convergent lens. Distant rays, they are coming and they are falling on a converging at one point. And if you do it with your hand lens, you will see at a particular point, a sharp dot will be formed. That dot is nothing but the image of the sun. And sun has high energy. So all the rays from the sun, you are converging them on one part. So the paper starts burning. Have you understood? So this is all about convergent. I think इतना समझ लेने से आपको एकदम clear हो जाएगा. Clear? Our next focus goes to now the next type of lens, which is known as the divergent lens. So before we begin with divergent lens, we will first understand what happens in a concave lens. इसका story थोड़ा अलग है और इसको समझना. So again we will have a principal axis. This is my principal axis, and on this principal axis, let us try to have the axis of our particular lens, and let's start building our lens. Okay, so our lens is this time a concave lens. So how does a concave lens look like? This is a concave lens, right? Concave lens. So obviously we have a O here. O is known as my optical center of the concave lens. So we'll again have a parallel beam of incident rays, with the condition that the rays are parallel to the principal axis. So let's take our parallel beam of incident rays. Okay. So I have taken one ray, I have taken one more, and they should be close to the principal axis. So 4 rays. Now I'll do a little bit of jugglery, otherwise I won't be able to balance out the figure. Now see, now it's not like, now this lens is known as a divergent lens. Don't expect that this lens will converge the rays. What is this lens going to do? This will diverge the rays. Okay, so when it diverges, please don't draw anything. Look at me, and I'm drawing with the wrong way. Why I'm drawing with the wrong way? In order that I'm able to maintain the geometry of this figure. So just hang on. Allow me to do something, and then only you will do your part. Don't you do this. This is something that I'm doing is a wrong way, but I have no other option. That's why I'm doing. Okay. Now see. Now the rays which were parallel to the principal axis, which came and hit or were incident on the concave mirror, they will no more converge, but they will get diverged out. Now I am drawing the first ray, first refracted ray. My first refracted ray will diverge out this way. Got it? My second refracted ray will diverge out in this manner. My third refracted ray will diverge out in this manner, and the fourth refracted ray is diverging out in this manner. Clear? Did you understand? Don't think of the dots now. Our story is yellow rays came and became green rays like this. Divergent. Diverge means they don't meet. So they're not meeting. My problem is that if they don't meet, I will not be able to define the focus of this lovely mirror. So what do I do? Sorry, lovely lens. So what do? I say that they diverge out, but is there a point where I can actually think in my mind where they appear to diverge from? Got it? आगे नहीं मिलते हैं, देखो बेटा, आगे नहीं मिलते हैं, सॉरी, आगे नहीं मिलते तो कहीं पीछे तो मिलता होगा ना. That is the story that we are trying to pull out here. So in this way, in this case, what do we use? We use this English word in optics. We use this English word in optics, which is known as, the word we will use is extrapolation. Extrapolation, or we call the rays are pulled backwards. Pulled backwards. And they are pulled backwards to create this lovely point of mine. And this point will be known as my principal focus now. So I now get my definition of what is known as the principal focus. Principal focus of a concave lens. Now let's try and see whether we can define. कैसे define करेंगे? देखो तो. Principal focus is a point. Where is the point on? Principal axis. What is the specialty? Rays which get refracted. Which type of rays? Parallel to principal axis. Rays which get refracted appear to diverge out from. So let's put our English together. आखिरी एकदम. The principal focus of a concave lens is a point on the principal axis from which refracted rays appear to diverge out after a beam of parallel rays parallel to the principal axis were incident upon this particular concave lens. So we can write it. The principal focus of a concave lens is a point on the principal axis from where rays parallel to principal axis appear to diverge out after being refracted by the concave lens. We learned it in grade 9 and see the definition still is there. याद रह जाता है. समझ के याद करो आप. Understood? So obviously here also the same story happens, that if the rays were parallel but were not parallel to the principal axis. So you may ask, sir, is there no focal plane here? My dear child, focal plane is there on every lens. So if the rays were not parallel to the principal axis, they would have appeared to diverge out from a point on the focal plane. Sir, do we have a focal length here also? Yes, we have a focal length here also. But slowly as we go and do mathematics, we will find that where it was the convex lens, the focal length was, look at the convex lens. Look at the convex lens. This I'll not teach you now, later. If I look at the convex lens, my focal length was measured from the optical center to the right hand side. And believe me, when we talk about focal length, we will be talking about our beloved child, not this one. It's all in relation to the principal focus. So how was the focal length? The focal length was measured from this side, because the focus came on the right hand side. But if you see here, the focus is on this side. So here also we'll have a focal length. But what is interesting is, here we will use two more things. One is called, in optics, two more words will run: real versus virtual. You must have learned this in mirrors also, but we will again see here. Real in anything in optics is, real means real, you will attribute the real word when there is actual intersection of rays. These rays can be incident rays, or these rays can be refracted, these rays can be reflected, whatever, but actual असलियत में merge करना. Now think of the convex lens case. In convex lens, the rays actually met. In this, the rays did not meet. You did some jugglery to make them meet out here. So here we will say rays do not meet actually. Have you understood, bacha? So if you talk about an image, what is an actual or a real image? A real image is formed by actual intersection of rays. What is a virtual image? A virtual image is formed by rays which actually did not intersect, but we had to make them intersect to get an image. Here we are not talking about real image. Here we are talking about, these are two adjectives that we will be using. So here when we talk about the principal focus, I will call this principal focus as a virtual focus. Sir, why are you calling it a virtual focus? Because this focus has been attributed not by actual intersection of rays, but by rays which has been thought, or you have pulled them backwards. Whereas if I look at this particular focus, then I will call this as a real focus. ये भी आपको 1 mark question कोई पूछ देगा. Is the focus of a concave lens real focus? No. The focus of a convex lens is a real focus. I rest for 1 minute and I leave it to you to ask any questions so far. The things that we have covered, is anything appearing Hebrew, Latin and Greek to you as I gulp some water? So far, देख लो. वो आपको वो लिस्ट चाहिए तो वो लिस्ट रेडी कर देता हूं. That list also is there. Where's the list? This is the list, and try to cover this list from the perspective of convex, concave, and just check whether you have understood or not. More important is, have you understood why I call it a real focus? Have you understood why I call it a virtual focus?
Sir,
Yeah. Taken your question, listen her.
concave lens, like an example of concave lens.
Concave lens, magnifying glass.
Okay, yeah.
Ask Ahiri what is her power. Ask her. She will say negative, minus something. You asked for concave or convex, beta? Concave is what Ahiri is wearing. All negative powers. What at this age, boys and girls, what you are wearing, 19, if I pick out 100 spectacle guys, 99 of them will be wearing concave lenses. They will all be minus power. These will study diseases. And you will get very rare child, उसका चश्मा देख के आपको लग जाएगा, it will be shining like anything. They are wearing convex. Their eyes will look much more bigger in size. That is rare. But if you ask me, sir, what are you wearing? I am wearing a plus specs. Mine is convex. My eyes are not bad. I am suffering from something called presbyopia, which you will also suffer. It comes from age. No one can. So when Ahiri will be coming at my age, she will be wearing something which is called bifocal, like the grandfathers and others wear a circle, because she already is having one disease which is known as myopia. And presbyopia will happen to all of you, including film stars also. The first symptom will be you will not be able to read properly. Like if I give you a credit card, you can't read that. If I open my specs, I can't even read the speedometer now. But if I wear this, it's okay. But if you ask me, can you read the board from here? Yeah, I can make out all of you. My near sight goes away. Whereas these children who are wearing specs, they can't read the board, but they can read the book very nicely. So they are called nearsighted. So we'll discuss this when we discuss about diseases. Any minus power chashma means concave. Any plus power chashma means convex. What are people of our ages? Plus minus both combined. Okay. I never had specs at her age, so my minus is not there. She will be having her minus and she will get a plus also. Nature's gift. That nobody can run away. Okay, bacha. So let me see your book. Converging, diverging. We have done principal axis, principal focus. much more. Now we come to something called ray diagrams. The method, first day is always a loser. Ray diagrams, come. Again, ray diagrams, these are diagrams that you have conceptualized as human beings, scientists and learners to understand the facets of refraction and image formation by lens. अच्छा, अभी जो diagram में हम rule सीखेंगे ना, you might ask, sir, in reality, does it happen like that when Ahri is wearing a concave lens, a ray which comes parallel passes like this? No. These all we have created. Why we have created? Otherwise, we need to justify how the images are formed. Right. So let's go for ray diagrams. And initially, the ray diagrams that we will all see with convex. As I told you, convex is studied in majority. Before understanding ray diagrams, you should first know some rules. Chale, aye. So you can give me some rest and make some basic diagrams bana lo, some rules. Rule number 1, rule number 2, and I think rule number 3. Okay. Rule 3. Your book also uses rule 3. 3 rules. Yeah, 3 rules. Fine. Rule 1, rule 2, rule 3. Understood? So let's just make our lens axis. And here it is. It's like making one big dosa and then cutting the dosa into 3, 4, just like the street vendor does. One lens. These are different cases, huh, children? So all of them will have an optical center. O. All of them will have a principal focus F. And then there is one more point that we also measure here, which is called 2F. 2F, have you understood? F, 2F. In mirror, we call it F and C, center of curvature. Here, there is no center of curvature, F and 2F. So are we ready for the rules? Okay, aa jao. Rule number 1. So I'll write it in short. My hands are paining now. You try to write it in full. Ray means incident ray. Parallel to principal axis, passes through focus after a refraction. So I will draw and show you. You will get to know it very easily. So a ray which is parallel to the principal axis, this is the first rule. Ray which is parallel to the principal axis, right? A ray which is parallel to principal axis, what will happen to it? It will pass through the focus. And these rules you have to know. Pass through the focus after refraction. Right? I call this as the maternal uncle. मतलब मामा का उल्टा साइड क्या होगा? बुआ होगा, पिन्नी, है ना? Mother's brother is mama. So for that mama's son, your mother is the pinni or the bua. Yes or no? That's the ulta rule of this. What is the ulta rule? The second rule will be, so you'll understand what nonsense this guy is speaking. Ray through the focus becomes parallel to PA after refraction. Ray through the focus, right? So a ray of light which is passing through the focus. Now in this, what focus we will take? Sir, listen. Sir, take this focus, a ray of light passing through the focus. No, my child. In optics, the incident ray always comes from left hand side to right hand side. I told you. So which focus we will consider now? The secondary focus. So a ray of light that passes through the focus like this and hits what you call the lens will become parallel to the principal axis. Just uska ulta pehle ka. Now Ashmita may say, sir, why did you take the ray this side only? can't you take the ray downwards like this from the focus? ऐसा भी तो हो सकता है ना कि ray वहां से नहीं, ray यहाँ से जाएगा, and she's correct. In this case, the ray will become parallel to principal axis in this manner. No issues, madam. Clear? ये मैंने लेकिन शॉर्ट में लिखा है. You kindly don't write it in short. Hey Ahiri, your hairs are all looking like Kappa now. You know that cartoon character Kappa? Kappa has all the hairs on front. Kappa.
Sir, thanks, sir.
You should put that rock star like bandana on your head.
Sir, just like
Oh, that is Jatadhari Shiv Maharaj. That one you are doing.
yes, sir.
Yes. Then you will look like, after that you can stretch your eyes a little bit in this way. An emperor of Japan, hero Tong Ching Kong Akihito, like that.
Sir,
You can be given that look. I don't mind. You can try. Nidhi, you can try with her that look. What you need to do is that you pull all her hair here like this, tie that band here, and allow the hair to fall off like a fountain. Like the Japanese, they tie like this. Make it tight, and then the pony will fall like a fountain. Stretch the eyes a bit. Kong shang kong yang tang, like that.
Can we try to look or do it?
Can we?
Can we look for any?
Oh, she and then we will click your picture and make a Ghibli avatar out of it. Ghibli.
Do it together.
Huh?
Get the rubber band.
Yeah.
So we come after and get all the rubber.
Yes, you can come with Rudraksh Mala also. First, we will make you Tapaswini Ahiri, and then we'll make you Yokoshima Nakikincho, like that. Okay. और third, वो तीसरा वाला लिख ले, फिर आज खत्म करेंगे. Third one is, and then we'll see different cases on the next class. The ray through the optical center goes undeflected. The ray through the optical center goes undeflected. Means if you have a ray which is passing through the optical center, ये आर पार चला जाएगा बच्चा, इसको कोई छू नहीं सकता है. See? The ray through the optical center goes undeflected. Clear, children? So based on this, we will have certain cases like where we will be putting our object and what type of. Yeah, please.
But how does it do that? Because there will be a change of medium and why will it also?
No. When it passes through the optical center, you remember in refraction also, if there was a ray which was making an angle of incidence 0 degree and which was that goes undeflected, the same case is this.
Okay, fine.
ठीक है? तो आज आपने, and I don't think, tell me honestly, whatever you studied so far, did you ever feel that you did not study some previous content and you didn't understand? Because none of the chapters are connected to each other, which means that if you have a problem with 3.2.2 or 3.2.1, I'm the person who will teach again. Don't worry about that. That's a different part that people don't tell me what the paper went, but I will teach you. But have you understood this content? This content does not pull any previous knowledge. If there was previous knowledge, I have brought it for you. So we'll stop here today and we meet on our next class. What are you doing in mathematics in school now? Please get an information which chapter you are doing. Let's not start a chapter which we are doing unnecessarily. Sets? Yes, then we'll do sets. Because sets and which was together, another chapter.